Welcome, everyone. Today, we will be discussing the concept of network software layer in computer network. To understand this topic, it is important to have a basic understanding of computer networking and the functions of the different layers in a network. A computer network is a set of interconnected devices that can communicate with each other to exchange data and share resources. To enable communication between devices in a network, the functions of the different layers in a network are divided into several abstraction layers. One of the most commonly used models for this purpose is the 7-layer OSI, Open Systems Interconnection, model. Each layer in the OSI model performs specific functions to enable communication between devices in a network. Let's take a closer look at each of the 7 layers in the OSI model. Physical layer. The physical layer is the lowest layer in the OSI model and it is responsible for transmitting the raw data bits over the network. It defines the electrical, mechanical, and functional specifications of the interfaces and media. This layer includes physical connectors, cables, and other networking hardware. Data link layer. The data link layer provides reliable transportation of data across a physical link. It performs error detection and correction, flow control and medium access control to avoid collisions. The data link layer divides the data into frames and adds a header and trailer to each frame to ensure reliable delivery. Network layer. The network layer is responsible for routing and forwarding data packets to their intended destinations. It performs functions such as addressing, subnetting, and routing. The network layer adds a header to each data packet, which includes the source and destination address and forwards the packet to the next hop. Transport layer. The transport layer provides reliable end-to-end communication between applications. It ensures that data is received in order, without duplicates or errors, and performs flow control to prevent overwhelming the receiving device. The two main protocols at the transport layer are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Session layer. The session layer manages the initiation, maintenance, and termination of communication sessions between applications. It provides a dialogue control and synchronization between the communicating devices. The session layer establishes and terminates connections between applications and manages the flow of data between them. Presentation layer. The presentation layer is responsible for converting data into a standard format that can be understood by all devices on the network. It performs functions such as data compression, encryption, and data conversion. The presentation layer ensures that data is presented in a format that can be understood by the application layer. Application layer. The application layer is the highest layer of the OSI model and provides the interface for the user to access network services. It supports application and end-user processes and provides network services such as email, file transfer, and other network access services. The application layer communicates directly with the user and provides the user interface for accessing network services. In conclusion, the OSI model provides a standardized framework for communication between devices in a network. Each layer in the OSI model performs specific functions to enable communication between devices in a network. Understanding the different layers and their functions is essential to understanding how networks function and how data is transmitted between devices in a network. Let's start with the TCP/IP model. The TCP/IP, Transmission Control Protocol/Internet Protocol, model is a 4-layer model used for communication on the Internet. The 4 layers are: Application layer. The application layer provides the interface for users to access network services. It includes protocols for email, file transfer, web services, and other network applications. Transport layer. The transport layer provides reliable end-to-end communication between applications. It performs functions such as error checking, flow control, and congestion control. The two main protocols are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Internet layer. The internet layer provides routing and forwarding of data packets across multiple networks. It performs functions such as addressing, subnetting, and routing. The main protocol is IP, Internet Protocol. Network access layer. The network access layer is responsible for transmitting data over the physical link. It provides the interface to the physical media and performs functions such as error detection, flow control, and media access control. As you can see, the TCP/IP model and the OSI model have some similarities, but there are also some key differences. The TCP/IP model is simpler and more focused on the internet, while the OSI model is more comprehensive and covers all types of networks. In conclusion, both the TCP/IP model and the OSI model play important roles in computer networking. Understanding these models is essential to understanding how networks function and how data is transmitted between devices in a network. Thank you for your attention, and I hope this lecture has been helpful in understanding the concepts of TCP/IP and OSI model in computer networking.